Hello everyone. Today I am going to discuss about derivatives of naphthalene. In today's lecture we will discuss about different derivatives of naphthalene and electrophilic substitution in naphthalene derivatives. Naphthalene derivatives like naphthols, naphthalamine, naphthoic acid and naphthoquinone. So first, derivatives of naphthalene undergoes substitution reaction, and the electrophilic substitution in monosubstituted naphthalenes, that is either substitution at one position or at two position, right? That is either one substituted or two substituted monosubstituted naphthalene depends upon the nature of group already present on the ring, right? When we are discussing about the electrophilic substitution reaction in derivatives of naphthalene. Derivatives of naphthalene, that means in naphthalene ring there is a presence of any group or substituent on the ring, right? So again, electrophilic substitution reaction in aromatic ring or in naphthalene ring again affected by the presence of that substituent or group, that is the nature of present substituent, right? So this electrophilic substitution in monosubstituted naphthalene depends upon the nature of group already present on the ring, right? As I said, monosubstituted naphthalene rings may be one substituted or two substituted, right? So in one substituted naphthalene ring, if substituent is an electron releasing group, then electrophilic substitution is homonuclear. That means the substitution occur on the same ring which carrying the substituent, right? And occurs at carbon number 2nd or 4th position, right? Keep in mind that in one substituted naphthalene, if electron releasing group present, then next substitution or electrophilic substitution occur in same ring which carrying the substituent, right? That is on carbon number 4 or 2nd position, right? If substituent is an electron withdrawing group, then electrophilic substitution is heteronuclear. That means the substitution will occur on other fused ring, right? And occurs either at 5th position or at 8th number carbon, right? Now, when in two substituted naphthalene, if substituent is an electron releasing group, then electrophilic substitution is again homonuclear as like in one substituted, right? Occur at position 5th or 8th, right? Further, if the substituent is a halogen, homonuclear, that's why occur at the within the same ring on which substituent present. Further, if the substituent is a halogen, right, or amino group, specifically electron releasing group, specifically halogen or amino group is present, then electrophilic substitution is homonuclear and occurs at 5th or 8th position. If substituent is electron withdrawing group, then substitution is heteronuclear and occurs at carbon number 5th or 8th position, right? And when electron releasing group then occurring within same ring at position 1st or 4th, right? Not 5th and 8th, sorry. In case of electron releasing groups, next substitution occur in same ring and on 1st or 4th carbon number, right, position. And if electron withdrawing group present, then electrophilic substitution is heteronuclear and occurs at 5th or 8th position. The derivatives of naphthalene are different, as I said, naphthals, naphthalamine, naphthoic acid and naphthaquinones, right? So let's discuss one by one. First one is naphthals. Two types of naphthols are available, that is either alpha naphthol or beta naphthol, right? Occurs in small quantities in coal tar. In industry, it can be formed by fusion of naphthalene sulfonic acid with sodium hydroxide. See here, its synthesis is given. In industry, naphthol, 1-naphthol or alpha naphthol can be prepared from naphthalene 1 sulfonic acid and it fused with sodium hydroxide to form 1-naphthol, right? To prepare 2-naphthol, naphthalene 2 sulfonic acid is taken, right? So when naphthalene 2 sulfonic acid is fused with sodium hydroxide, it will form 2-naphthol or beta-naphthol. Next, synthesis is from 1-naphthylamine, right? 1-naphthol can be prepared by hydrolysis of 1-naphthylamine, right, with sulfuric acid at 180 degrees Celsius temperature, and it will produce 1-naphthol. Next, chemical reactions of naphthol. 1-naphthol react with benzene diazonium chloride salt. This reaction is known as the coupling reaction, right? Naphthol undergo coupling reaction with benzene diazonium salt and form the azodide. One example is given. 1-naphthol react with benzene diazonium chloride and form 4-phenylazo 1-naphthol, right? Same 2-naphthol can also coupled with this benzene diazonium chloride and form 1-phenylazo 2-naphthol, right? First preference is attachment of this diazonium group to the para position to the OH group, right? So when 1-naphthol is used, then this diazonium group attached at the 4th position or para position to the OH group, and when 2-naphthol is used, then this phenylazo group or diazonium group attached to the first position of the naphthol, right? So it forms the 1-phenylazo 2-naphthol. This is the coupling reaction. Next derivative is naphthylamine. Naphthylamine can be synthesized from naphthol, that is known as the Buckler reaction, right? It can be obtained from the naphthol, and this reaction is known as the Buckler reaction. Naphthylamines can be prepared from naphthols by heating with aqueous solution of ammonium hydrogen sulfide and ammonia. See here, NH4H SO4 SO3, that is the ammonium hydrogen sulfide, right? And ammonia NH3. Right, so when 1-naphthol is heated with ammonium hydrogen sulfide and ammonia, that will produce the 1-naphthylamine. Right, same reaction when carried out with 2-naphthol, then it will produce the 2-naphthylamine. See here reaction, 2-naphthol is heated with ammonium hydrogen sulfide and ammonia, then it will produce the 2-naphthylamine. Next, synthesis for the naphthylamine, that 1-nitronaphthalene is reduced with the help of stannous and hydrochloric acid to produce 1-naphthylamine. Right, here simply reduction of nitro group occur. This nitro group NO2 group is reduced with the help of stannous and hydrochloride reducing agent and converted into amine group or amino group NH2 group, right? So 1-nitronaphthalene is converted or is reduced to the 1-naphthylamine. Next, chemical reactions of naphthylamine. 1-naphthylamine react with sulfuric acid, right, and produce the naphthyonic acid, right? When 1-naphthyl react with sulfuric acid, it is naphthoic acid, which is used in industry or in dye industry specifically, right? Simply, one naphthylamine is heated with sulfuric acid, it will form the naphthalenic acid. What happens in this reaction? Simply, electrophilic substitution reaction, sulfonation of naphthylamine, right? In one naphthylamine is one substituted naphthalene derivative. That's why substitution occur is homonuclear. That means it within the same ring, right? As we discussed. So and amino group is electron releasing group, right? That's why it occur at the substitution occur at the fourth position, right? Second or fourth position, right? So here substitution of sulfonic acid group occur at the fourth position or para to the NH2 group, and this structure is known as the naphthalenic acid. Next reaction, when one naphthylamine or two naphthylamine is diazotized with sodium nitrate, that is NaNO2, in presence of hydrochloric acid, right? At the low temperature, in cold condition, that is less than 5 degrees Celsius temperature, then it will yield naphthalene 1 diazonium chloride, right? And 2 naphthylamine produces the naphthalene 2 diazonium chloride, right? And as we know that this diazonium chloride salts has the different synthetic application, right? Different chemical reagents can be, or chemical compound can be prepared or can be synthesized by using these diazonium chloride salts. Keep in mind that this is the diazotization reaction. That's why here temperature of the reaction is very important. This reaction or the product only obtained when the reaction is carried out in cold condition. That is, the temperature of the reaction mixture should be less than 5 degrees Celsius. Then and then you will get the product, right? If temperature raises more than 5 degree, right, or in hot condition, diazonium salts, different diazonium salts get degraded, right, and that's why that cannot be used for the further synthesis of the different chemical compound, right. Next, chemical reactions of the naphthylamine are different electrophilic substitution reaction, right. First one is reaction with copper halide, right, CuX, that is copper halide, and X may be, that is halide may be chlorine or bromine, right. So when this is the reaction of the naphthalene diazonium chloride salt, right. In previous diazotization reaction, naphthalene diazonium chloride salts is obtained, right. As I said that these salts are further salts can be further used for the synthesis of different organic or chemical compound, right. So here some examples of this synthesis or synthetic application of this naphthalene 1 diazonium chloride is given. So see, first when naphthalene diazonium chloride undergoes or react with copper halide CuX, then undergoes the halogenation and form one halonaphthalene. This whole diazonium chloride group can be replaced with the halide, right. So it can be formed one halonaphthalene, right. Now when this naphthalene diazonium chloride react with potassium iodide, then iodination of the naphthalene ring occur and form one iodo-naphthalene. Right. Next, nitration. This naphthalene diazonium chloride react with sodium nitrate, then it will form the 1-nitronaphthalene. Nitration of the ring occur. When naphthalene diazonium chloride heated in presence of water, right, it will lead to the hydrolysis and it form the 1-naphthol, right. OH group replaces the diazonium chloride group, right, and form the 1-naphthol, right. Next, when naphthalene diazonium chloride reacted with H3PO2, that is the phosphorus acid, hypophosphorus acid, right, then it will produces the naphthalene, that is the replacement of diazonium chloride group with hydrogen atom, right. Simply this whole group, diazonium chloride group is replaced with the help of hydrogen atom. That's why simply naphthalene ring is produced. Then naphthalene diazonium chloride react with copper cyanide and form 1-cyanonaphthalene, right. Cyanide group replaces the diazonium chloride group. Simply 1-cyanonaphthalene is produced. When this 1-cyanonaphthalene undergoes reduction with the help of lithium aluminium hydride, that is reducing agent, right, then it will form the 1-amino-methyl naphthalene, right, 1-amino-methyl naphthalene. That means C triple bond and cyano group reduced to the CH2NH2 group, right. In C triple bond and 2 pi bonds are present. These 2 pi bonds are reduced with the help of hydrogen atoms and that is from lithium aluminium hydride and converted into CH2NH2 group, right, amino methyl group. So these are the synthetic application of the naphthalene diazonium chloride salts, right. By using these naphthalene diazonium chloride salts, different naphthalene derivatives can be prepared, right. Halonaphthalene, iodonaphthalene, nitronaphthalene, naphthol, naphthacene, then aminomethyl naphthalene, right. When here in place of naphthalene 1 diazonium chloride, naphthalene 2 diazonium chloride is used, then 2 substituted different product or derivative of naphthalene can be obtained, right. So these are the synthetic application of naphthalene diazonium chloride salts. Next derivative is naphthoic acid, right. Naphthoic acid can be prepared by using the different synthetic reaction. For example, first from Grignard reagent, right. Naphthoic acid can be prepared from the Grignard reagent. Here 1 bromonaphthalene react with magnesium ether in presence of react with magnesium and in presence of ether, then it will form the 1-naphthyl magnesium bromide. This is the example of Grignard reagent. First of all, Grignard reagent is prepared, right, from the naphthyl bromide. You can say naphthyl bromide, that is the example of alkyl halide or aryl halide, right. So 1 bromonaphthalene react with magnesium in presence of ether and form 1-naphthyl magnesium bromide. It is example of Grignard reagent, right. And on hydrolysis and reaction with carbon dioxide, this 1-naphthyl magnesium bromide converted into 1-naphthoic acid. Second synthesis by iodoform reaction. Naphthoic acid can be also produced or prepared by iodoform reaction. In this reaction, first of all, naphthalene undergoes the electrophilic aromatic substitution reaction, that is the Friedel-Crafts acylation, right. Naphthalene react with acetyl chloride, that is CH3COCl acetyl chloride, and cause the acylation of the naphthalene ring, right, and form 2-acetyl naphthalene. Now this 2-acetyl naphthalene react with NaOH and iodine and undergoes hydrolysis, acid hydrolysis, and form 2-naphthoic acid. This reaction condition is for the iodoform reaction, right. So 2-acetyl naphthalene undergoes iodoform reaction and form 2-naphthoic acid and releases the iodoform CH(I3), that is iodoform. That here in this reaction iodoform is produced, that's why it is known as the iodoform reaction. Next, Kolbe-Schmitt reaction. Naphthoic acid can be prepared by using the Kolbe-Schmitt reaction. Right? This reaction produces the different product that is temperature dependent. Right? At low temperature, sodium salt of 2-naphthol on reaction with carbon dioxide yields 2-hydroxy-1-naphthoic acid. Right? And at high temperature, this sodium salt of 2-naphthol react with carbon dioxide at 240 degrees Celsius temperature and form 3-hydroxy-2-naphthoic acid. Right? All over produces the hydroxy-naphthoic acid, but positions of the carboxylic acid group and hydroxyl group are different according to the temperature. Right? Then another derivative of naphthalene is 1,2-naphthoquinone. Right? Depending about the position of two carbonyl groups, maybe in the same ring or in different ring, there are three types of naphthaquinone. That is 1,2-naphthaquinone, 1,4-naphthaquinone and 2,6-naphthaquinone. Right? The synthesis of all these three naphthaquinone are here given. First, let's see synthesis of 1,2-naphthaquinone. Right? 2-naphthol react with benzene diazonium chloride and form this corresponding dye. Right? That is 1-phenylazo-2-naphthol. Right? This intermediate or dye is 1-phenylazo-2-naphthol. Right? This intermediate or this compound undergoes the reduction with the help of lithium aluminum hydride and form this compound that is 1-amino-2-naphthol. Right? 1-amino-2-naphthol. Now this 1-amino-2-naphthol when is heated with chromic acid produces the 1,2-naphthaquinone. Right? So it is the synthesis of 1,2-naphthaquinone. Next one is synthesis of 1,4-naphthaquinone. When 1-naphthol react with benzene diazonium chloride, it will produces the 4-phenylazo-1-naphthol. Right? 4-phenylazo at in 1-naphthol at 4th position phenylazo group is present. That's why 4-phenyl-1-naphthol produced. Right? This compound undergoes reduction with the help of lithium aluminum hydride and form 4-amino-1-naphthol. Right? 4-amino-1-naphthol. Again, this 4-amino-1-naphthol is heated with chromic acid to produce 1,4-naphthaquinone. Right? This 1,4 indicate the position of the double bond or ketone group. Right? Here this ketone group present at the 1,2 position, here in the 1,4 position. Then preparation of 2,6-naphthaquinone. This 2,6-naphthaquinone can be produced with the help of 2,6-dihydroxynaphthalene. Right? When this 2,6-dihydroxynaphthalene is oxidized with the help of lead oxide, PbO2, that is lead oxide, it will form the 2,6-naphthaquinone. Right? So these are the synthesis of different naphthaquinone. 1,2, 1,4. Here there is a problem of the double bond. This bond is not present, should be not present here. Right? This bond should be not here. Right? in 1,4-naphthaquinone, here only one bond should be present here, right? It should be not present. Right? This is okay, 2,6-naphthaquinone. Then chemical reaction of 1,4-naphthaquinone. Right? 1,4-naphthaquinone undergoes cycloaddition, that is the Diels-Alder reaction. Right? At low temperature with butadiene in presence of stannous chloride, right, and form anthraquinone. Right? Naphthaquinone undergoes the Diels-Alder reaction. Right? React with butadiene, right, conjugated diene, that is butadiene, 1,4-naphthaquinone, that is the dienophile, butadiene, it is the conjugated diene, react with each other, undergoes cycloaddition reaction in presence of stannous chloride and at low temperature form anthraquinone. So these are the different derivatives of the naphthalene. There are naphthols, naphthylamine, naphthoic acid and naphthaquinone. Okay? Thank you.